I Truptikate, SPPU University, FPL2 subject Unit-4. In this video, we will going to see introduction to Android, web, and embedded systems. So, marking system for this unit is having 10 questions and of 12 marks. 8 questions of 1 marks, 2 questions of 2 marks. This is the syllabus. History of mobile software development. The first cell phone was the Motorola Dynatec 8000X in the year 1973, which was developed by the Martin Cooper. So, he is the father of cell phone, Martin Cooper. In 1994, IBM Simon was the first to use software application concept of apps. In 1996, Motorola StarTAC was the first flip-flop mobile. In 2000, Ericsson R380 marketed as the first smartphone, Ericsson. 2003, BlackBerry was released. In 2007, we have first Apple iPhone in the market. In 2008, HTC Dream or T-Mobile G1 is the first to run on the Android. Overview of Android OS. Android is a mobile platform consists of operating system, middleware, key apps. Android specially developed for applications. Android is open source. Android offers a unified approach to application development for mobile devices, which means developers need only to develop for Android, and their application should be able to run on different devices powered by Android. It is special operating system used for the mobile. These are some of the Android mobiles. Origin of Android. Android was founded in Palo Alto, California in October 2003 by Andy Rubin, Rick Miner, Nick Sears, and Chris White, who worked at Google to develop. Andy Rubin is co-founder of Android. Android is owned by Google. Google purchased Android in 2005. Android was purchased by the Google in August 2005 for $50 million. Android beta released 12 November 2007. The Open Handset Alliance (OHA) is a group of several companies which are allowed to use Android. Was formed on 5 November 2007. The Android SDK was first issued as an early look release in November 2007. In September 2008, T-Mobile HTC Dream announced as the first mobile based on the Android, the first smartphone based on Android platform. A few days after that, Google announced the availability of Android SDK release candidate 1.0 in October 2008. Google made the source code of Android platform available to the general public. Means that Android made open source under the Apache's open source license. Google's Android logo derived from the Atari's game called Gauntlet, the third encounter. This is the logo of Android. Open Handset Alliance. What is Open Handset Alliance? Open Handset Alliance is a business alliance consisting of 84 companies to develop open standards for mobile devices. They are used to accelerate innovation in mobile and offers consumers a richer, less expensive, and better mobile experience. This consists of companies which are handset manufacturers, semiconductor companies, commercialization companies, software companies, and mobile operators. It's a consortium group of 84 several companies. This group of companies are allowed to use source code of Android and develop applications. Reason for Nokia not to develop Android mobiles is Nokia is not a part of OHA in 2007, but nowadays we have Nokia having Android, which announced in 2007. These are some of the companies which are under OHA, Open Handset Alliance. Android architecture. Android architecture has 3 main components: operating system, middleware, and key apps. Operating system. Android is purely based on the Linux operating system. If you see that Linux operating system takes 3 GB, so how it could be possible that within 1 GB in our mobile we have the Linux operating system? This is because we have inherited the features of Linux kernel, not whole Linux, from the Linux operating system, and from that we made the Android operating system. So in Android operating system, it is used, Linux kernel is used as device driver management, memory management, process management, networking device, and it is also act as an interface between applications and hardwares. So it allows you to interact hardware devices with your mobiles. Key apps. By default in Android we have some of the applications which are already present. Some of the applications which are written in C or C++, in some in Java, some in .NET language. C or C++ apps need NDK, Native Development Kit. Java application requires Software Development Kit, SDK. Nowadays Java applications are used. And middleware. Middleware is the portion which is used to interact with application and operating system and the other world. So in that, what is application framework? Application framework is a framework which consists of infrastructure or code for application which is ready-made. So it consists of infrastructure for apps with ready-made libraries. Suppose you want to create a new application, so instead of writing thousands and much more lines, you have some of the code which is already available. These libraries are present in the application frameworks. These are purely based on the Java. It consists of API interfaces. It has activity manager. It acts as an activity manager, manages application lifecycle. It has window manager, content providers, view system, package manager, telephony manager, resource manager, location managers. Libraries. These are the libraries which are coded in C or C++. Our applications are written in, most of they are written in C or Java languages, but if we want to interact our application with the operating system, and some of the codes are written in C or C++, so we interact by using these libraries. These libraries are also called as a native libraries. These are C or C++ library. These are interfaced through the Java. So it has Surface Manager, OpenGL, SGL, Media Framework, Free Type, so many. So if you want to create, suppose if you want to play any animation video, so these are animation video consists of OpenGL. So OpenGL is written in C or C++. This is under the library. So this, by using this OpenGL library, we play the mobile on any apps. Next is Android runtime. To run any application on your mobile, we need Android runtime. So normally our Java code is converted into dot class by using Java Development Kit, and this dot class, this is called as a bytecode. This is get converted into the binary file by using JVM, Java Virtual Machine. But in our Android, as this code are very large in size, we cannot execute this on less memory with less power. So what we do here in Android, we convert the Java code into the dot class, means a bytecode, by using JDK, and this bytecode again get converted into the another bytecode format, which is the DEX. Now this conversion task is done by the DVM machine, Dalvik Virtual Machine. This machine is soul of your Android. It is the main component which converts your Java bytecode into its own bytecode, and it convert into the .dex formats. Once this get converted into the .dex file, now again these are given to the Dalvik Virtual Machine, and then they are get converted into the binary file. Now they are given to the others for the executions. So in Android runtime, we have two main components, core libraries and Dalvik Virtual Machine. Core libraries consist of codes which we used for running our applications, and the Dalvik Virtual Machine, this machine is used for converting bytecode, Java bytecode, into the Dalvik Virtual Machine's bytecode, as we have very less memory, less power. So this need to be converted into the smaller reduced format, and then they are get executed. There are some of the Android based tablets. So as Android, when originally written and developed, it was only for the mobile. So we can say that Android is an platform, not a mobile platform, which consists of operating system, middleware and key apps. These are Android versions until now. Android versions are alphabetically named, that Android, Alpha, Beta, Cupcake, Donut, Eclair, Froyo, Gingerbread, Honeycomb, Ice Cream Sandwich, Jelly Bean, Kit Kat, Lollipop, Marshmallow, Nougat and Oreo. When we have Android versions, along with that we have some of the name that is called API level. What is this API level? API level is the integer number given to any versions of the Android, which is specially used for the developers to uniquely identify Android operating systems. What are some Android P-name predictions? These are the predictions of Android versions: Android Pancake, Android Beta, Android Popsicle, Android Pumpkin Pie, Android Pastis, Android Beta. Android versus other operating system: Apple Inc., Microsoft, Nokia, Palm, Research in Motion, Symbian. Other than Android, there are several other mobile operating systems which is used. Symbian, iOS, Windows, these are one of the most used mobile operating systems. Sales comparison of OS. Features of Android. Android is open source, larger developer and community reach, increased marketing, inter-app integration, reduced cost development, high success ratio, rich development environment. Android can run multiple apps at the same time. It also supports optimized graphics, VGA, 2D graphics, 3D graphics. Android has better app market. Android lets you change your settings faster. It gives you more options to fit your budget. Android keeps information visible on your home screen. Android also supports Java application interface that is better than the previous touchscreen mobiles. User gets millions of apps that user cannot get in any other mobile operating system. Android supports advanced audio, video, still media formats such as MPEG, H.264, MP3, AAC, AMR, so many. Developing an Android application is not tough using SDK, standard development kit, and Java emulator. We can easily develop application that we want. Android Lifecycle. Android Activity Lifecycle. What is Android Activity? Before start, Android Activities is a single screen in Android. It is like a window or a frame of Java. Android Activity Lifecycle is controlled by 7 methods. These methods are on create, on start, on resume, on pause, on stop, on destroy, and on restart. On create, suppose you are playing any video on your Android mobiles. This single screen is called as Android Activity. On create will be called when activity is first created. On start, called when activity is becoming visible to user. Suppose I am playing the video, when that will be get created, so on create method will be get called. On start means my video will be get start. On start method will be get called. On resume, call when activity will start interacting with the user. On pause, called when an activity is not visible to the user. On stop, this callback is called when the activity is no longer visible. Suppose my video gets stopped, video played, and at the end it gets stopped. So on stop will be get called. On destroy, this callback is called before the activity is destroyed by the system. I want to close this video, so I will call on destroy. So this will be get called to the system. On restart, this callback is called when the activity restart after stopping it. My video gets stopped, then if I want to restart the video, I will restart here, but inside behind the back on restart method is get called. Important notes for Android based MCQ. What is an activity in Android? Activity performs the action on the screen, or it is a single screen of your mobile. What is ANR in Android? ANR stands for Android application not responding. ANR, application not responding. When the application is not responding, ANR will occur. A class that does not have a name but have functionalities. No name. So it is called as anonymous class. Layout in Android: linear layout, table layout, frame layout, relative layout. Sleep mode: only radio interface layer and alarm are in active mode. ADB stands for Android debug bridge. Intent is used to pass data between activities. Intent used to pass data between two activities means, suppose data can be read from local sources XML in Android through XML resource parser. Services runs in the background and doesn't have any UI component. Services are the application or data which runs in the background. Initial screen of application, any application, is called as splash screen in Android. The XML file that contains all the text that your application uses, that is called as strings.xml. The R file is automatically generated file. In Android, Java bytecode is compiled into Dalvik bytecode. It uses Dex compiler. DVM is responsible for running application on Android. The development of the Dalvik virtual machine is started in 2005. These are some of the abbreviations. ADB stands for Android Debug Bridge, APK Android Package Kit, JSON JavaScript Object Notion, AVD Android Virtual Device, DVM Dalvik Virtual Machine, ADT Android Development Tool. ADB Android Debug Bridge it gives you the command interface to interact with your mobile. APK Android Package Kit, JSON JavaScript Object Notion. This is used when you are using the web pages on your Android. These get converted. Web pages are converted using JSON and viewed on the mobiles. AVD stands for Android Virtual Device. This device, I am saying this mobile, this is not the actual mobile, but this is the virtual image of your mobile. So this is called as a virtual mobile or Android Virtual Device, and the software which you to create this virtual environment. These are called as Android development tools. Some of the Android development tools are Android Studio and so many. Main components in Android are Android Activity, Android Fragment. Android Activity is the single screen. Android Fragment subcomponents in Android Activity: intent service, content provider, and broadcast receiver. Content provider provides you the content from the mobile, and broadcast receiver gives you the message from the system to the mobile. WAP, Wireless Application Protocol, empowers mobile users with wireless devices to easily access and interact with information and services. A standard created by wireless and internet companies to enable internet access from a cellular phone. Webforum.org, co-founded by Ericsson, Motorola, Nokia, Phone.com. 450 members in 2000, comprise of handset manufacturers, wireless service providers, ISPs, software companies in the wireless industry. Goals of WAP is to deliver internet services to mobile devices. It means that to enable mobile internet service we need WAP. Browser, microprocessor similar to existing web browsers. Markup language similar to HTML adapted to mobile devices. That language is WML, wireless markup language. Script language similar to JavaScript adapted to mobile devices. Gateway, transition from wireless to wide wall. Protocol layers, transport layer, security layer, session layer, etc. Server, WAP or origin server, similar to existing web servers. Telephony application interface, access to telephony functions. This is the internet model. Here in this internet model, client gives the request for the web pages in the form of HTML, and that is delivered to the web server. Web server searches for the content and it gives the reply of that content as a web page to the client. All this happen in the HTML and they are followed under the HTTP protocol. These are the rules which are used for transferring the data over the internet. Why we need WAP? Wireless networks and phones have specific needs and requirements that are not addressed by existing internet technologies. WAP enables any data transports, TCP/IP, UDP/IP, GURTS, SMS or USSD. It optimizes the content and air-link protocols. It utilizes plain web HTTP servers, leverages existing development methodologies, utilizes standard internet markup language technology. All WML content is accessed via HTTP requests. WML UI components map well onto existing mobile phone user interfaces. No re-education of the end users, leveraging market penetration of mobile devices. Several modular entities together form a fully compliant internet entity. HTTP or HTML not enough. Why? Because when we want to access the web pages through HTML, the data is very large. So in mobile, as our memory is small and power is also small, so for that we need something which has this powerful feature, the web pages features, but in the reduced format. For mobiles we use WML language, and for that transfer we use WAP, Wireless Application Protocol. This WAP protocol is the protocol or set of rule which is followed when we are transferring WML contents. WAP architecture. WAP architecture has three main components: client, web gateway and web server. Normally client send request to web server and web server give response to client, but as our mobile is reduced device and on mobiles our content are displayed in the reduced format, memory is also reduced and power of CPU is also slow. So for that we need something which can translate this content and which can reduce excess amount of data, extra data. So here client send request of any web pages to web gateway. Web gateway then sees this and give request to the web server. Web server give response in the form of HTML or HTTP. So in that web gateway see the content of all that, and then it reduces the excess extra material and then it gives a response to client on the mobile. WML, Wireless Markup Language. WML is tag-based browsing language. It takes into account limited display navigation capabilities of devices. It is XML-based language. It has cards and decks. It has events, variables, and state management. WML basic unit is a card. Cards are grouped together into decks. Document deck. All decks must contain document prolog and WML element. This is one example of WML language. Example, it consists of navigation, variables, input method, and these are the cards. Web protocol stack. Web protocol stack has multiple layers. In that, layers names are application layer, session layer, transaction layer, security layer, transport layer. These are controlled by WAE, Wireless Application Environment, WSP, Wireless Session Protocol, WDP, Wireless Transaction Protocol, WTLS, Wireless Transport Layer Security, WDP, Wireless Datagram Protocol. Web microbrowser. As you see here in this mobile, you are having the content of web page, but these are reduced in format. Their images are also very compressed. So web microbrowser supports for optimized for wireless devices. It has minimal RAM, ROM, display, CPU and keys. Provides consistent service UI across devices. It provides internet compatibility. It enables wide array of available content and applications. Web trees. Web enables mobile phone users to retrieve information from the internet. True. WML and WML script are based on HTML and JavaScript. True. Which of the following is not a layer protocol in web? That is HTTP, because it is another protocol. Web will not provide an interface to voicemail or prepaid statement. No, it's false, because it provides the internet facility. What does WAP stands for? WAP stands for Wireless Application Protocol. Embedded systems. Embedded means something that is attached to another thing. An embedded system is a microcontroller based, software driven, reliable, real-time control system. An embedded system can be thought of as a computer hardware system having software embedded in it, which is used to perform dedicated tasks. Means, if we take one example, embedded system remote control, the hardware and software both are used as a system for the devices. That is called as an embedded system. It has real-time operating system. This is example of microcontroller. Here, if on a chip we have all the components which are necessary for execution of any task, CPU, memory, all these are embedded in a single chip, then we say that is a microcontroller. Difference between microprocessor and a microcontroller. A microprocessor is a single VLSI chip having a CPU. In addition, it may also have other units such as floating point processing, arithmetic unit, and so many. Earlier generation microprocessor fetch and execute cycle was guided by a clock frequency of order 1 MHz. Processors now operate at a clock frequency of 2 GHz. This is my CPU. This only performs execution of processes. The external devices which are connected to CPU are RAM, ROM, IO port, timers. Microcontroller. A microcontroller is a single chip VLSI unit, also called as a microcomputer, which, although having limited computational capabilities, possesses enhanced input or output capabilities and a number of on-chip functional units. Microcontrollers are particularly used in embedded systems for real-time control application with on-chip program memory and devices. In this chip, I have CPU, RAM, ROM, IO port, timer, serial COM port. All these components are embedded in a single chip. So I say that this is a microcontroller. Characteristics of an embedded system. Embedded system is single function, tightly constrained, reactive, and real-time. Microprocessor or microcontroller based. It has its own memory. It is connected. It is hardware and software system. Embedded system consists of ASIP, memory, analog input-output, digital input-output, and processor core. Basic structure of an embedded system: sensor, analog to digital converter, processor, memory, digital to analog converter, actuator. Advantages or disadvantages of embedded system. Advantages: it is easily customizable, low power consumption, low cost, enhanced performance. Disadvantages: high development effort, larger time to market. Embedded system architecture type. There are two types of architecture for an embedded system: Von Neumann architecture and Harvard architecture. Von Neumann architecture: data and code lie in the same memory block. Then the architecture is referred as Von Neumann architecture. Harvard architecture: when data and code lie in different memory blocks, then the architecture is referred as Harvard architecture. Von Neumann architecture: as you see here, RAM and ROM are consists in a single memory block. RAM consists of data, ROM has program. So this is called as von Neumann architecture. And in our architecture, we have separate memory block for RAM for data and separate memory block for ROM for programs. So in this architecture, we have two buses for communicating data and program separately. So at the same time, we can run both RAM or ROM. Von Neumann architecture versus Harvard architecture. Von Neumann architecture is a single memory based. It has both code and data inside a single memory. Harvard architecture, it has separate memories for code and data. Von Neumann architecture is higher speed. Harvard architecture is slower in speed. Von Neumann architecture, it has simple in design. Harvard architecture, complex in design. Von Neumann architecture, processor needs to fetch two different clock cycles for performing data and code together, and in Harvard architecture, for using data and code at the same time, we can run both that at the same time. Normally so let's start by programming embedded systems. Normally when we compile our C program, they get converted into the binary code, and when we execute this binary or hexadecimal code, we get the output. In embedded systems, we have C program. So the C programs are compiled into the hexadecimal code format. These hexadecimal codes are written onto the microcontroller chips, and then we say our chip is active, it is embedded system. These chips can be used in a real environment. Then we say that the microcontroller is an embedded system. This is the flow how we write the codes in the microcontroller. C program language, C code program gets compiled. When we compile C program, we get binary or hexadecimal code file. That file is written on the microcontroller chip, and then when we execute this, we say our microcontroller or embedded system is active. This is also one of the example. Factors for selecting the programming language. We should have size. The memory that the program occupies is very important, as embedded processors like microcontrollers have a very limited amount of RAM. Speed. The programs must be very fast. That is, they must run as fast as possible. Hardware should not be slowed down due to a slow running software. Portability. The same program can be compiled for different processors. Ease of implementation, ease of maintenance, readability. C for embedded system. It is a mid-level with high-level features such as support for functions and modules, and low-level features such as good access to hardware via pointers. C is the most common embedded language. 85% of embedded applications are coded in C. C, when used correctly, is as safe and robust as any other high-level language. It directly manipulates the hardware and memory addresses. It is very efficient. It is popular and well understood. Good, well-proven compilers are available for every embedded processor, 8-bit to 32-bit. C51 cross-compiler supports all of the ANSI standard C directives. Compiler versus cross-compiler. What is the difference between compiler and cross-compiler? Compiler is a software tool that converts a source code written in a high-level language on top of a particular operating system running on a specific target processor architecture. Cross-compiler are software tools used in cross-platform development applications. In cross-platform development, the compiler running on a particular target processor's operating system converts the source code to machine code for a target processor whose architecture and instruction set is different from the current development environment operating system. In simple words, compiler translate high-level language into the low-level language on a single machine. Cross-compilers has the capabilities to translate high-level language into low-level language, and the low-level language can be of 8-bit processor, 16-bit processor, 32-bit processor. Any bit processors can understand this language, so the compilers is called as a cross-compilers. The data types used in the embedded systems are bit, signed char, unsigned char, enum, signed short, signed int, unsigned int, signed long, float, s-bit, SFR. I will suggest before writing code for any embedded system, you should have understanding of hardware which you going to use for any embedded system. You should have very basic knowledge about their pin diagrams, what they are doing and what they're functioning. So this is 8051 microcontroller. We write programs for any embedded system inside this microcontroller. Let's see one example of embedded system. This is the C program written for turning on 8 different LEDs connected to a single microcontroller. This is my microcontroller 8051. On port 1 I have connected 8 different LEDs. On each port pin, on port P1 we have 8 different pin, and on each pin we have connected a single LED. So here this is my program. So I will discuss about the program. Hash include register 51.h. This is processor directive. Why we need this? Because we are using 8051 register, 8051 microcontroller. So the protocol for that, all the port information is maintained in register 51.h header file. The next function, the important function, is the main function. Whatever we write inside the main function in C language, only that will be get executed. So we have to write the code for turning on, turning off LEDs in the main function. Void main function. Inside this I have initially what I did, I maintained all the port 1 component as a 0. Means if I say port 1 all component 0, it will directly turn off all the LED. So if I am saying the port 1 is equal to 0x00, 0x stands for hexadecimal value. Here this is means whatever we have after that, that is the hexadecimal value. So first 0 and second 0. So second 0, it starts from the LSB. So this is 0 represented in a 4-bit format, this 0 represented in the 4-bit format. So this is pin 1 dot 0, this is port 1 dot first pin, port 1 dot second pin, port 1 dot third pin, port 1 dot fourth, fifth, sixth, seventh pin of all the port 1. So all they are kept as a 0, means if I am sending 0 message to my LED, they will turn off. And I want to make them turn on, so I have to send the one message, I have to send 1 to LED. So what I am doing, I am making port 1 is equal to 0x for hexadecimal value, and for this I have to send 11111111. So hexadecimal format for 1111 is F, and for 1111 is F. So here P1 is equal to 0xFF. So here all the ports pins are becoming 1, means your LED will turn on, then LED followed by LED will turn off. But this happens in a microseconds, so you cannot be able to see whether they are turning on or off. We should give some delay in between. So for providing delay, we have used another function, that is void delay, and here we are passing the microsecond values int. So this is the function. Here we are writing no extra code, we are just looping them inside for loops. We are doing nothing inside the for loops. This is because we want to add more delay. So in this function we have only used for loop, for loop, for loops. So this will give you the delay. This is the simple example of turning 8 different LEDs connected to port 1 of my microcontroller. The next example, how to send any message on the LCD screen. Before writing the code for that, you should understand what is the LCD and what are the pin configuration of your LCD. Here this LCD is a 16 pin LCD. Here VSS, VDD and VEE, these pins are used for providing voltage values. RS, RW and E, these are the important pins. RS is the pin which is used to select the display data on or off. If I am setting RS is equal to 1, then I will be able to send the data on my LCD. Anything can be get displayed. RW for the read or write select signal. E for enabling read or write signal. And these 8 pins are used for the data, actual data in the 8-bit format. Here I am writing the code in that P2 port is used for connecting data on the LCD, and for connecting RS, RW, E I have used port 1. So RS is connected to port 1's 0th pin, RW is connected to port 1's first pin, E is connected to port 1's second pin. So in this example, my main function is only the main function. Inside main function, before writing actual data, I should clear my LCD, I should set my LCD, I should provide the voltage on LCD. So the first I will dictate that on this my LCD I have 2 rows for displaying data. So here the code is 0x38, and as we are only providing the commands, we are not providing data, so our RS pin will be set to 0. So in that I'm using function LCD CMD, and inside that RS is set to 0. The same way for clearing screen we have 0x01, for cursor blinking 0x10, for displaying on our LCD we have 0x0C, and bring the cursor to the first position we have 0x81 value. After that, this is only the command given to LCD, we have not given any data on LCD. Now our LCD is prepared, we can send the data. So after that we can send the data. So first I'm sending letter A, and after that I'm giving the pause or delay. So for the delay we are just using the for loop. Now here I want to send the data, so I have to make the RS pin as 1. So in this code I'm using the function LCD data, and my RS pin is set to 1. RS pin stands for whether you are sending any data on the LCD. So as this one, so my capital A character will be sent on my LCD screen. Then I will send I, and then IT. So it will display AIT. Thank you.